All right, I always love these afternoon sessions. It's not clear whether you're going to get the people who are actually going to sleep through it or they've had enough for the day and they're ready to go home. And again, as mentioned, I'm going to do this in English. Hopefully that's not a huge deal for everybody. I'm Will Duckworth from comScore. I've been at comScore for about 14 years now, and I run the what's called the core processing group at comScore, and so we're responsible for the data after it's been collected all the way through aggregation and reporting. So I'm going to talk today a little bit about a couple of different things, because one of the fun things in putting these presentations together is there's a section of the audience that wants this to be very deep and technical. There's another section of the audience that wants to understand the business implications, and we've got to kind of go back and forth between those two. So I will endeavor to kind of cover both areas at a higher level, and if we have questions or things we need to talk about, we can either do it after this, or I've been hanging out in the MapR booth, which is number 18, just across the way a little bit, and we can talk about it some more there. So let's get started. Who here is familiar with comScore? Show of hands, who's, okay. How many people have a smartphone? Okay, yeah. How many people have a tablet? How many people have a smart TV? Okay. How many people have seen advertising on the internet? Yeah, okay. No, you've never seen advertising on the internet? You block. Yeah. Okay, so we're going to talk about all of that, including some of the ad blocking as well during this. So comScore, for those of you who don't know who we are, what our mission is making audiences and advertising more valuable. We do that with a total view of the consumer, and by a total view of the consumer, what I'm talking about is we see the activity on the smartphones, we see the activity on their PC, we see the activity on their tablets, and we can match that up with offline data as well. And so we can then provide trusted metrics and information to both sides of the advertising equation, the buy and the sell side. We are a recognized leader in this area in the market. 48 out of the 50 US online properties, 10 of the largest internet companies global. These are all names that you certainly would have heard of. And that all leads to a slide something like this, showing our 25,000 clients across all of the verticals. You can probably look at this and pick out several companies that you're familiar with in these areas. So we also partner with a lot of companies also in this space to make our data even more valuable. I would point out a couple of these. Datalogics is one that we work with. IRI is one that another one. Lotame and Seismic. One that I'd like to specifically point out, because I've done a lot of work with them, is AppNexus. So comScore data, and by comScore data I mean our syndicated products, so from where people are going and what people are doing on the internet, but then that data is available as well as what we refer to as trust profiles, so that would be information about the viewability of a particular website, or how much invalid traffic we see, which is something we're going to talk about here in a little bit. That information is available in AppNexus pre-bid, so that as an advertiser, you have access to that data, and you can use that in the evaluation of whether or not you want to place that ad on that site at that particular period of time. So in order to do this, we have very large data sets. We have, the slide says massive and unparalleled, and I guess I would kind of agree with that. Just moving through this, comScore has a 2 million person global panel that's opt-in on the PC side. That's all. Then into that, we feed about 1.8 trillion records on a monthly basis from our census network. So that's small pieces of JavaScript running on the web pages that you visit. And then from our partners, and also through some of the work that we do, we have 1.6 billion demographic profiles that we use with that data. And then we can link up with offline information to get the partner sales data. And so we can cover about 90% of the US households with that. So this leads to this kind of a problem, which is what I have to deal with on a daily basis. And this graph runs from the 2009 timeframe through the most recently closed month for us, which would be August. And as you can see, in August, we were working on about 1.8 trillion records. This is a combination of both the census and the panel data. And this is really where we started to get into big data. Prior to this slide, we still had quite a bit of data, or a fair amount of data, or however you want to look at that. We were processing in a completely different realm at that point. We used to buy 31 servers, and we would put a day's worth of data on each one of those servers, and then when you were ready to run a month, you would just kick off one day on each server and then have it all come to a single server to be aggregated for the monthly view. In this time frame is when we started to realize that we weren't going to be able to keep that kind of scale in terms of the number of servers, and we needed to go much wider. Where does all this census data come from? So here's a graph. What this is actually showing is a heat map of where the census records are coming in from. That's pretty good coverage. That it's hard to argue. You're hitting all the major areas. 21 trillion events in 2014. And on a monthly basis, we see about 15 billion distinct cookies. And there's about 7 billion people in the world. So we can kind of do the math there. It's multiple. It's obviously going to be multiple devices. It's people deleting cookies, things like that. So really high-level data flow. This is way above even the 10,000-foot view. But essentially, these two pieces of data coming in, these two data sources, the panel and the census data, both flow in to our collection environment. And this collection environment, we have a bunch of custom code that does the ETL on this data and makes it available. And part of that ETL process is done by SyncSort, which if folks aren't familiar with that, I would strongly suggest taking a look at it. They're a company that really started out in the mainframe space and has since branched out into servers and PC, the PC side of it, and their sort and ETL software is very good. And we make use of it quite a bit, not only for sorting, but also for compaction. And most recently, we've started using it for actually generating output files in Parquet, as opposed to tab-delimited gzip files. And then from there, it flows into two separate systems. We do dual load, one into our analytics data warehouse, which is the back end of that is Greenplum, and the other into Hadoop. And we use MapR as our distribution. I'll talk more about both of these platforms in a minute, but just bear in mind, we do it both directions for a couple of reasons. One of the most specific is we use the analytics data warehouse for our analysts to be able to get in and actually mine for the data and create the new methodologies that we're then going to implement within the batch processing Hadoop environment. Our analysts are very well versed in SQL. They can write some of the most ungodly SQL you've ever seen. And so we want to give them as much of a real-time access to that data as possible. And so hourly basis, both of those are loaded into the ADW and into Hadoop. Once processing is done, it flows into the EDW. This is the reporting system. So reports for clients can come out of here, as well as higher level, higher grain data, aggregated data that we can make available later on. So our Greenplum cluster at this point, 200 nodes, and this is actually, it's holding about, let's see, I think we have 60 days of the census data within this environment right now. And Hadoop cluster is 450 nodes right now. It'll be over 500 by the end of the year. This is a little over 10 petabytes of storage. We run about 70,000 jobs a day through this cluster. Those jobs are a mix of ad hoc and production jobs, although my team is primarily responsible for the care and feeding of this, and I try to keep as many ad hoc jobs out of this cluster as possible. We also have an integration and a development cluster where we try to run more of those ad hoc jobs. But we're in the neighborhood of 70,000 jobs a day, Pig and Java MapReduce. And our distribution is MapR, actually we're running M7 now, but we are on the 3.1 code line. Okay, so I want to talk about mobile a little bit, hence the questions about mobile phones earlier in the talk. So this is starting to get into some of the things that you can generate, or the kind of the insights you can have when you start, when you get to this kind of scale and you can run these kind of jobs. Really interesting thing here is penetration of smartphones. So the graph starts in the December 2005 and runs through December of 2014. That's a pretty nice curve for anybody in business to see as far as penetration is concerned. We're up to 75% and increasing about 10 percentage points per year. So how does that break down? So that breaks down, time period for this graph is the same. It's December of 2005 to 2015. And you can see that early on you had a lot of people using the Palm devices. You get some of the Symbian in there, Microsoft, and then BlackBerry. And then as you move across the chart, you can see iOS coming in, Android coming in, relative shares changing significantly. So Android, this information is coming out of our mobile metrics products. Android is still number one, and iOS is a strong second. However, when you then turn that and you look at the OEM on that, Apple is by far your largest OEM, and then Samsung is the largest among the Android folks. And then you still also have some feature phones out there and with their breakdown. Okay, so multi-platform. So what I'm talking about when I'm talking about multi-platform is the PC, tablet, smartphone, television, all those kind of things. What are we seeing across that? So there was a lot of, I guess, press and conversations recently regarding TV and how much people are watching TV, and is advertising on TV dead, and all of these kind of things. My argument would be that TV's not dead, we're just tending to watch it on a whole lot of different rectangular boxes than we used to. And that's kind of what this slide is showing, is that we're still we're jumping in the amount of media that's being consumed. It's just coming in on different things. It's coming in on smartphones, it's coming in on tablets, it's coming in on desktop, as opposed to just your regular television set. So this is a challenge for advertisers and content providers to try to figure out how are we going to be targeting these newer forms, these newer platforms. Multi-platform right now is largely a younger demographic area to consume, and so we can see, the 18 to 34s are coming along, and then the 55 plus. So the rest of us, those of us in the middle there, in that middle stripe, I'm sure we'll get it figured out at some point. And again, on multi-platform, this is just a cut that allows us, that's looking at the different types of consumption that's going on in terms of content category. Some interesting things that I would point out here is that if you look, portals and finance and news are still being largely consumed on PCs, on desktop devices. But if you then swing over and you look at things like maps and photos and even gaming at this point, are all heavily skewed towards mobile. Yes, sir? I'm sorry? Well, mobile would be tablets within there. You can get a little, well, particularly with some of the larger ones, right? You're alluding to, is that a PC or is that a, yeah, it's still something I can pick up and lug around, right? So, all right, so then this comes together in advertising. All right, so ad viewability. So ad viewability is here is what we're looking at is when that ad is displayed on that page, is it viewable? Did it get to the page? Did it get to potentially a section where somebody could look at it? Is it in view, above the fold, below the fold? Has it been blocked at some point? Those kind of things. So there's been a lot of work within the industry to optimize ad delivery. but this number really still has not changed that much. So what we're looking at here is potentially an issue where ad fraud is coming in. Blocking is certainly some of it, but fraud is probably a larger portion of it. Mobile advertising is proving to be very effective. We do a lot of lift studies, and certainly some of them are showing that you get better audience awareness, you get people are more receptive to it at that point if it's coming in mobile. But then there's a large amount of, there's quite a bit of non-human, or the newer term for non-human traffic is IVT, or invalid traffic, that's coming in, and really a majority of the IVT that's out there is on a very small amount of the total campaigns, but we're still talking about a multi-billion-dollar a year industry. So there's still work there in trying to determine how some of that ad fraud is getting out into the environment. So this is a look at one of the comScore interfaces. This is specifically the Campaign Essentials interface, which is showing that across campaigns, because it can be difficult to look across all of your campaigns, but just your in-view, audible and visible, validated in target, and brand safe. So the in-view, we were talking a little bit about validated in target, meaning that you're hitting the right people that you were trying to hit with your campaign, and brand safety is that from the standpoint of is this on the right page? Because we certainly don't. If I'm an airline, I certainly don't want my ad running on a news site that is talking about an airline accident. So that would be a brand safety type of thing. Most of these need to be done in real time during the either the bid process or during the display. All right, so now we get to invalid traffic. So this is just some of the articles that have been out recently regarding invalid traffic and regarding some of the issues that causes. So this hits both sides of the ecosystem, right? So if I'm a seller and there's a lot of invalid traffic, then there's a lack of trust, it can damage my relationships, I can lose a lot of revenue because of it. On the buy side, I've wasted money in placing that ad or allowing that ad to be placed somewhere that it's not going to be seen by a customer or a potential customer. And then I get lack of transparency, and then I don't have as much opportunity for my ad to make its impact. We look at a lot of different types of look at a lot of different types of IVT. Some of them you have the botnets, which I'm sure most of you are aware of. There's actually been a lot of conversations, a lot of things in the press recently regarding botnets on mobile. So that's a growing problem as well. Browser hijacks. There are a lot of, I don't know if any of you have ever gone to Google's homepage and actually seen an ad on the homepage for Google. If you have, that's normally a browser that's been hijacked. You will also have companies that are installing browser hijacks that allow them to replace ads within the slot on the page. So spiders, content scrapers, click farms. We've found entire sites that are just very small pixel or 1 pixel size frames, where you can't see any of the ads that are on that page, but believe me, there are thousands of ads that are running on that page. So comScore is uniquely positioned to address a lot of these different types of fraud. So we have 3 different areas that we're collecting, right? So one of them is the ad tag. So these are tags that are fired at the campaign and in some cases ad slot or placement level. Those fire in real time, and they allow us to see what's actually supposed to be being displayed there. And then in addition to that, we have our census network, which we talked about, and then we have the panel data or the human data. So we're going to talk a little bit now about how all of these come together. So as soon as the tag is fired, we can collect a lot of telemetry data about all of those ads. we can see what was displayed, what was the creative that was displayed, where was it on the page, and then we have the additional information allows us to then look at that and say, okay, can we figure out if these bots or these click farms? In addition to that, we have the global panel, which allows us to look at human behavior. This is one of those things when you're modeling this that you really need. You've got to establish what would a normal person look like? What would their normal traffic pattern through the site be? How long will they stay on a particular page, the dwell time, things like that. So that helps from the human side. Then the census panel allows us to see where traffic is really going on about 1.5 billion domains across the internet, and see the additional information about patterns from there. So together, those two pieces together between the panel and the census and the ad tags are helping us to identify what is actually human activity versus the rest of the bots. So in order to do this, and I would suggest that this is kind of where maybe big data can come into some other businesses, no matter which side of this equation you're on, even if you're just running a small website for your company, or you're advertising at a global scale, some of the interesting things that you can do, or some of the things you should be thinking about as far as IVT detection is concerned. The first thing is you need to establish a baseline. You've got to try to figure out what's normal for your site, what's normal for the types of places where your ad runs, okay? And then you've got to somehow get some data on what kind of things are bad traffic, IVT traffic on your site. So can you put some captchas in, or are there URLs that you're seeing that people are accessing on your site that shouldn't normally be accessible, or is there demand for the site very sequential in nature? Or people are jumping to random URLs on your site, or URLs that are set up as random sites that they wouldn't normally be able to get to as a user. So then you've got to look at your population. What are the baselines that you typically see? Whether this is user agents, click rates, URL pathing, things that I was discussing. So that's where you got to establish those metrics, right? And then in one example here, we're looking at different browser types. This is actually a pretty good way to view traffic. Most of your bots are going to run, some of the more sophisticated ones will actually use a list, but we've actually seen some cases where you have with the same browser hitting millions of times on a particular website. In other cases, we've seen multiple browsers all hitting from the same IP address, all within a very short time range hitting the website. So overall, the approaches for IVT detection is you need to automate this. It needs to run frequently, whatever frequently is defined for your individual businesses. That could be hourly, that could be daily, that could be weekly, monthly. You need to add in the telemetry to either portions of your site or to your advertisements so that you can actually get to this information. You need to establish shunt processes, and by those, I mean, how do you shut it off if you do see that there is traffic that's coming into your site or hitting your advertising that you don't want to be there? How can you shut that down? And then in some cases, particularly in the advertising area, what you see is the implementation of clawbacks. So the ability within a reasonable amount of time for somebody to come back and say, I don't want, I'm not going to pay you for these particular impressions because I believe they were IVT. So, any questions?
No? Then I'm going to thank you very much.
Okay.
Will you still be here? So
yes,
if people
I'll be
prefer
here.
To ask questions face to face.
Yep, I'm here for the rest of the day today. I'll be over in booth 18.
All right. Thanks very much.
Thank you.
Thanks.